Welcome to Spring LIB.
The concepts of energy, which is in terms of joules, and then power, which is in terms of joules per second. Of course, solar power will stay constant, or relatively constant, because the sun has a constant power output. So solar energy, on the other hand, we can actually, if it helps, it's better to write an equation. Solar energy could be equaling essentially the solar power multiplied by a time interval. In this case, they're saying about twice as much solar hours than it does in 1 hour, simply because solar energy is directly proportional to the change in time. Solar power is, of course, constant. Energy outputting will always stay constant unless some large event occurs with the sun, such as a supernova or something of that sort. But at this current state, the solar power will, of course, stay constant. And that's simply deriving the of power. We're just putting the word solar because sun. And then solar energy would, of course, be sheer amount. So multiplying solar power, whatever that output is, by a time interval would give us a total amount of, and that solar energy is not always reaching Earth, of course, because a lot of it is being deflected away in the form of, if all UV rays were to hit Earth, it would be very unhealthy to go outside. However, Earth has shielding, and it has a magnetic field, and it has a bunch of essentially it has an atmosphere, and a bunch of factors play in to account in the fact that not all solar reach Earth. For the she coming from the sun, you simply multiply the constant power output, the solar power, multiplied by time interval. The end of the solution. Thank you for watching.